Hello, everybody. Today we want to talk about data visualization lesson 4. Lesson 4 is a very important lesson as well. It's about Seaborn. Okay, to get started, we are gonna first of all, as always, import NumPy as NP and import pandas as PD, matplotlib.pyplot as PLT, and then Seaborn as SNS. If you have problems with Seaborn, you can start with having conda install Seaborn and then do that. Some of the examples that we have in this chapter are from the book Data Visualization in Python by Daniel Nelson. And some of them are from myself and other resources. Okay, what is Seaborn? Seaborn is a statistical library which builds the capability, which builds on capabilities of matplotlib. So Seaborn was designed to augment matplotlib's functions and tools, addressing some of the common issues that users have with matplotlib. So it's something like that is for in addition to matplotlib. Seaborn comes packaged with a number of test data sets. We are going to talk about them. You can access these included data sets utilizing the load underscore dataset function. Let's try loading in datasets and visualizing some of them. So for that, we are going to start with, for example, dataset tips. Tips equals sns.load underscore dataset tips data. And then after that, we are going to take a look at the dataset head. As you can see, we have these variables. We have total bill, we have tip, we have sex, we have smoker, we have day, we have time, we have size. So you can guess it's a data set about people going to restaurants and having maybe a dinner, maybe a lunch. Size, how many restaurant people are on the same table. What day of the week is it? Is it smoker or non-smoker? Sex. And then how much was the bill and how much they paid tip. So these are the information we have. With the second data sets that we have is flight data set. That data set we have year, month, and number of passengers that we have. This third data set is IRIS, very famous data set. It's about some flowers and some information about the um, uh, sepal length and sepal width and sepal pedal length and pedal width and species. Yeah, that's the third data set that we have. The fourth data set is the famous data set Titanic, and it has some information about, let's see, uh, if people survived or not, passenger class, sex, age, deck, embark town, alive, alone, some variables like that. And then, as always, so first of all, just as always, use import OS to set the data set on a folder you want. And we are going to have this data set that is the real data set that I have. And take a look at the head of this data set. So variables that it has is name of the student, gender, if they're male or female, assignment. So this is a data set that we worked with before. It's a real data set in one of my classes. Assignments are out of 200, exam 1 is out of 150, exam 2 out of 150, exam 3 out of 150, final exam out of 350, total is out of 1000, and then grade is the alphabetical grade that they get. So these are the data sets we are going to be working with, and plots in Seaborn created by calling the Seaborn library along with the desired plot function. So we are going to see this over and over again. Okay, let's talk about the first type of plots that we have, distribution plots. Distribution plots, for example, number one, and maybe the most important one is univariate, is, for example, histogram. So you can use a dist plot. So, for example, here we are doing data set SNS, the dist plot tips total bill. You can also do this in another way, which is also a little bit maybe more famous. So it's going to be or, and then here you're going to say the name of variable that you have, comma, and then the name of dataset that you have. So the dataset is tips, and then you can easily plot this. Oops. So as we just saw, just having this SNS.displot tips total bill gives us a histogram with KDE. So sometimes maybe you want just the histogram but not KDE. If you want that, you do this. Or if you, for example, you want opposite, let's say that you want KDE, but you don't want, for example, you just want the KDE, but you don't want the histogram. So for that one, you say hist equals false, and you only get KDE. Sometimes it may, so this is only KDE. If you want, but if you want only KDE, you do this. Only KDE does the, you do this, you just say hist false. And if you want KDE with rod plots. So rod plots, as we are going to see in a little bit, it shows like you can take a look at this here and you see that it's like a lot of points, a lot of like small lines here. It means that wherever you have, for one, every observation that you have, you're going to have a small line here. So when there are a lot of observations, then there's going to be like a, this area is going to be like very crowded. But so with this plot, we saw that how we can get a histogram with KDE, without KDE, KDE without histogram, or for example, KDE with rug. So remember that the default is that KDE is true and hist is true. But if you want to turn them off, you just say KDE equals false or hist equals false. And if you want anything else to be added to your graph, you can turn them on. For example, rug, you just have to say rug equals true. Now, you can also have the option to have a KDE plot with just sns.kde plot. So that's also an option. So rather than saying, so these two are exactly equal to each other. Either you can have this one or this one. They're the same thing, yeah? So SNS.displot tips total bills hist equals false, or SNS.kd plot tips total bill. You can turn on the shade if you want, so the area on the curve would be shaded, colored, and then, or you can have, for example, rock plot. If you want, you can have it like this, or you can have it like rot plot on, and then you could just have the KDE equals false. Excuse me. So that was about distribution plot for univariates. How about distribution plots for bivariates? That's also very easy. For example, scatter plots. Yes, that's one of the easiest ones and most important ones. So all you gotta say is sns.scatterplot. X equals the variable you want, y equals the variable you want, and then data equals df. And you get this scatter plot. And if you want a scatter plot with a regression line, you're going to use sns.regplot. That gives you scatter plot with a regression line. You can have, if you have this sns.regplot and then have the fit underscore reg equals false, then you get again histogram. But if you want, for example, reg plots, and you say scatter equals false, you get only the regression file. So these like something like regplot is called a parent function. Yeah, you can get scatter plots out of this regplot. Yeah, something like this plot is a parent function. Something is a like a regplot is the parent function. So I'm gonna have the parent function first and then specific ones. Another kind of plot that we can have is joint plot. Sometimes you want to visualize multiple features against each other and then and their distribution as well. We use joint plot for that. So remember, this was like particularly hard in Matplotlib. Here it's like really easy. It's way easier. You get the SNS dot joint plot and then X and Y and data equals tips, kind equals scatter. You get whatever you want. Pair plots display pairwise relationship. So that was about joint plots. The next topic that we have is pair plots. Pair plot displays pair plots display pairwise relationship, which shows possible pairs for each of the variables in the dataset and a univariate. Plot along the diagonal. Univariates plotted along the diagonal. So example number one, pair plot of IRIS datasets. So as you can see, it's a little bit of, first of all, bigger, but you have the data set of, for example, of different variables. So here we have 4 variables. So 4 by 4, we get 16 plots. On the diagonal, we get a univariate of each of these variables. And then here we get, for example, sepal width versus the third variable that we have versus, for example, pedal. So here this okay, sorry. This one here, for example, is showing pedal width versus pedal length, and you see that there is a very good correlation here. Okay, so that's about pair plots, and you can see how easy it is to get pair plots. So sometimes you can add some stuff. For example, you can categorize them with respect to hue. So here we have 3 colors because we have 3 species. We have so we say hue equals species. So each species would be in different color. Yeah. Each species is going to be in different color, and then yeah, that's gonna give us very good plot. Another one example that we can have is let's say another example, SNS dot pair plots. Then let's say we want data set DF. We get assignments versus exam 1, exam 2, exam 3, and the final exam. So we get everything right there. It's a very good graph. And we have all of them here. Now here, for example, you can have, for example, hue equals, let's see what variables we have here. For example, we want hue equals, let's say, gender. Yes, let me take a look at datasets df head to see what variables I have there. So yeah, I have gender, which is either M or F. So let's say I want hue equals gender. I do this. It's going to take a few seconds. But when I do this, so you see that I'm getting like two different colors for two genders. Yes, for male versus female. It's right here, so you can see it's a little big, but if you want to be able to see it, you have to make this bigger. But M is blue, F is green, and you can see you have different colors. Of course, you can change the colors and everything, but okay. That was another example. Change pair plot kind. So let's see how that works. For example, SNS, pair plot IRIS, hue species, but here we have two more arguments. Kind equals reg, diag kind hist. So we want our pair plot to have the kind reg, and then diagonally we want to be histogram. So this is exactly what we got. And on the diagonal we got histogram. Another example, let's say pair plot for tips. So we have three numerical variables here: total bill, tip, and size. You can have hue equals sex, so male versus female is different. And male is blue, female is green. And you can also have line plots. Line plots for that, we do this. So let's say x values are numbers between 1 to 5, yes? So remember, NP range starts from 1, but it ends at, it covers the range 1 to 6, 1 inclusive, 6 exclusive. So we know this from NumPy. So 1 is inclusive, 6 is exclusive. And then y values are, let's say, some numbers, 10, 12, 13, 16, 17. You want the pie plot, you just say SNS dot. You want the line plot, you say SNS dot line plot. X equals X vals, Y equals Y vals. And then if you don't say this plt.show, this guy will be printed like something like this. But it just depends if you care about that or not. In Spider, it's not much a difference. But okay, next kind of plots that we want to talk about is categorical plots. Categorical plots, we use cat plots. You can visualize very different like kinds of plots like violin plot, box plot, bar plot, strip plot, swarm plot, Boxen plot, point plot, and or a count plot. Yeah. So essentially, this cat plot is another parent function. So pand function are functions that you can change the inside you can change with these options that you have. So this plot is a pand function, uh, and out of that you can get different sorts of function. This plot is one of them, and then rug plot is reg plot is one of them, and then so I'm going to just write parent function here. Out of this you can get different plots. Yeah, so reg plot is a parent function. This plot is a dist plot is a parent function, and then now this one cat plot is a parent function. Yes, so cat plot, and the format for cat plot is we start with the sns.catplot, and then we have x equals something, y equals something. You can have hue, you're gonna have data equals something, and then kind. So let's see a couple of examples. For example, data set Titanic, x equals 6, y equals survived. Have that. Female, you can see 75% of them survived, males under 20%. Cat plots, it's this one. You have the kind equals box, so we get a box plot for our variable x, and then cat plot, again cat plots x. Now these examples with dataset tips, violent plot if we want. You can see that the male versus female variable y is tip, and then swarm plots, and then strip plots, and then count plots. For count plots, you gotta have only, let's say, one variable, not two, and then boxen plots as well. They are all here. Okay, so we saw that this cat plot is a parent function. Now let's talk about bar plots. For example, let's have this data set df2 that we had before, 4 people, 4 heights, and we want the bar plots. We can have SNS dot bar plots. So bar plots, we could have it in cat plot, or we can have it independently. So when we are having that independently, so we are saying this. We are saying SNS.barplot x equals df2 name, and then y equals df2 height, and then just run that. We get this, or you could say something like this. You get the same thing. Example number 2. Dataset Titanic, x equals 6, y equals survived. So exactly the same thing that we had on cat plot, now with bar plot. As you see, you get the same result. Example number 3, for example, in dataset df, x is df grade, y is df exam 1, and we see that, for example, A's get like the exam 1 is really good, around 140, B's a little bit less, C exam 1, and F is like has the lowest exam 1. So again, these are like actual data, so it's interesting to me for sure, the way that from exam 1 you can realize if someone is going to fail or someone is going to do really good. And to plot a bar plot horizontally instead of vertically, we can simply switch the places of x and y variables. So data set that we had before, it's going to be just if you start with uh, X is df2 height, and then Y is name. It's going to be horizontal. If you want to change the color, you can just easily do that. Just say color equals blue, and you get a blue color. Or you can set the palette arguments. So here palette argument equals HLS. You get this one. Plots grouped bar plot in Seaborn. How does that work? So for example, sex versus survived, and then we want that to be uh, distinguished or characterized by a class. So if you have, maybe you have seen the movie Titanic or not, but in the Titanic, it was three passenger classes: first class, second class, third class. So we have two genders. We have male and female, and then we have three different classes. So we have the survival, let's say, chances or probability, and then here we say x equals sex, y is survived, hue class. So we have differentiated. So you see that first class in all of them, they survived more, and then second class, and then third class. And so female first class, all of them almost survived, yeah. But female third class, only maybe 50% of them. Male third class had the lowest chances of survival. Okay, ordering group bars in a bar plot with a Seaborn. So let's see what's happening here. So this one is done. So for example, here we have male first and then female. Maybe you prefer female to start with female and then male. So done by the order argument. So you're gonna have an order argument, which is a list, and it takes the values and the order that you would like to have. So we run this. It's gonna be similar to before, but first we're gonna have female and then we're gonna have male. Yeah. Okay, change the confidence interval. Let's say that for some reason you don't, so confidence interval is this CI. You can have this CI equals none, or you can have some other options, but actually the biggest difference here is that you don't have this line here if you didn't want to, which shows the some kind of variation in data. Okay. Uh, If you want to change the estimator, you can also do that. For example, here it shows the estimator here. So the defaults in estimators when we had a bar plot of sex versus total bar was the mean, but now it's the standard deviation. It shows standard deviation of different male versus female. So you can see that male have a little bit more standard deviation. But here it doesn't show the mean of each X. It shows another thing. So we can have count plot again. We had that count plot before. So in cat plot, we had this, but you can have that independently as well if you want. So if you want, you can have this, and that's the same thing. You can have box plots. So again, we had that before, but if you want the box plot, you can have this. For example, day versus total bill, data set tips, or for example, if you want by hue equals smoker, so you have smoker versus non-smoker, and then day of the week. We can have violent plots, so we already saw violent plots. They essentially show the same summary statistics as box plots, but they also include additional information. The shape of the violin in violent plot is a kernel density estimation, or KDE, that we have that represent the shape and distribution of the data. So again, for violent plot, you can either use that cat plot that we saw, or you can use violin plot directly. So something like this, and or you can have it something like this. Sex is X, age is Y, data set Titanic. So all of that, you could have done all of this in Catplot or just independently. Okay, with that being said, let's move on. You can set the labels as well if you want. So for example, x equals SNS dot violin plot, and then you want to set the labels. So you can do this, and then you have the x equals sex, y equals age, data equals Titanic. We just saw that. But now the only difference is that we have y label, we have x label, we have title. These are like very similar to before. So x dot set underscore title dot underscore y label underscore x label. Very similar to before. And a little bit like more examples here in violin plots. Sorry if sometimes I mispronounce violin plot, violin plot. Uh, so here you can split the data for male versus female and their total bill. So male is blue and then female is green. So you can do that. Or smoker versus total bill. Another example of violin plot. Next topic again is strip plot. Again, you can have strip plot from cat plot, or you can have it independently. And then you can always remember that you can set the figure size if you want. You can always do that. So this one, the figure size is set 9 and 7. Also, we have hue equals passenger class. We have 3 passenger classes. And then between people who died, who survived, who didn't survive. And example 3, x equals, again, strip plot. So, but it's a little bit different. We have hue equals sex, but we have the jitter argument also on. You can also make this equals false and run that. You get this one. But so if it is true, you get something like this. So X is day of the week. We have data for 4 days: Thursday, Friday, Saturday, Sunday. And Y is total bill. And then hue is sex, is male versus female. Yes, for each day we have that. And then we have swarm plots. Again, you can have this swarm plot directly or from cat plot, but essentially it's something like this. Or you can, again, you can use X and you can use fixed size. This one, when you have X, is very good, essentially, and necessary when you want to have multiple graphs together. So in that case, your X is going to have like, you have a couple of rows, couple of columns, but essentially this is what's going to happen. So data set is IRIS, X is species, and then Y is pedal length. And you can see that the pedal length is different for each species. And yeah, so again, all of these are can be done in cat plot as well. And factor plots is something like this: each day of the week, and then Y is total bill. I think it's very similar to bar plots, but okay. Next one, very important thing that we have is heat maps. So let's say that tips correlation, we have that as, so it's this data set, total bill. So we have three numerical variables right there. We have total bill, we have tip, we have size. We can have them here in dataset TC, or you can have this, let's say TC, just right here. It doesn't matter. You can have it here, and then just run this. Yeah. So, or you can have this dataset TC first, just have it right here, and then here use TC. It doesn't matter. But you do this, you get the heat map. Yeah, total bill versus tip versus size, and the correlation that they have. So you can see that total bill has the correlation with size is 0.6, with tip is 0.68, and with itself is obviously 1. And we are using the C map of cool warm. Example number 2 is about flights. So this example, we are using something that we learned in chapter in pandas. Yeah, we are using pivot table. So dataset is dataset flights. And let's take a look at that dataset a little bit one more time. We have year, we have month, we have number of passengers. So we are going to have index as month, and we are going to have values as passengers, and our columns are going to be year. So if I run this, and then if I take a look at dataset DF3, then DF3 is going to be something like this. Yeah. So we have different years from 1949 to 1960. We have different months, and then, but essentially dataset is something like this. Now, so compare it with what we had here before. Here we had it in this format. Each year we had like month, but now we have it and then passenger. Now we have passengers inside this table, but our table is like 12 years from 1949 to 1960 and 12 months. And each number is, for example, this one is January 1949. So you can easily pivot this table, but after pivoting this table, you can use that to have a heat map. So with this heat map, you can see that generally speaking, the number of passengers is highest in months like January and July and August, yeah. And then as the year increases, number of passengers increases as well. So maybe the economy gets better and we're gonna have more and more passengers. Example number 3, but it gives a very good insight to our data set and what's going on. Yeah. Example number 3 that we have here is, for example, data set DF. So I'm gonna have a fig x and then as on. So here, again, remember this is very important when you are having like a few uh, plots together. I'm defining x exam1 underscore core, the correlation of that with all variables, and then I want the heat map. So if I want the heat map, I do this heat map, and I get the heat map. Hmm. Okay, not sure why I'm not getting this. Run this all together. Yeah, when you run all of them together, you get a heat map. And you can see the exam 1, the correlation with different variables, with assignments point 12, with exam 1, 1. So it's correlation matrix, but only for exam 1 with everything else. Let's say we don't care about the correlation between exam 2 and other stuff, just exam 1 with all other variables. Then you can do this. So it's essentially the same thing as before, but only I'm defining exam 1 underscore core df.core, just exam 1. Okay, with that being said, we can have some grids. So let's say IRIS species value counts. Let's take a look at that one first. So we have 50 species in each of them. We have 3 species. I'm not going to even read them. Uh, but with that SNS pair plots, we can get the pair plot of our data sets. And yeah, as you can see, you have the pair plot. So 4 numerical variables you have here, and then you can have it like this as well. If you run everything together, you get uh, essentially you get this. Or you could just do this. Yeah. With this one, you're gonna get KDE plots for lower ones, and you get the scatter one, and then on upper one. So let's take a look at this one more time. We are getting G map. So we are saying G equals SNS per grid. So the diagonal G dot map underscore diag is this plot. Yes. So histograms of everything with KDE. Upper diagonal we want to be scatter plots. So as you can see, these three are scatter. These 6 plots are scatter plots. And lower we want KDE plots. So here you can see below the diagonal, these are all KDE. Yeah. Okay, facet. Plotting multiple um, scatter plots with facet grid. You can do all that as well. So example number 1, G equals SNS facet grid. So you have to, first we are defining the facet grid. So data equals tips, column equals time, row equals smoker. And then with that being said, I'm going to have this plot of that with total bill. So you'd run that, you get this one. So let's see what's going on here. We say column equals time. So we have time equals lunch or time equals dinner. So we have 2 different columns. Smoker can be either yes or no. So we say row equals smoker. So first row is smoker equals yes. Second row is smoker equals no. Data equals tips. And then we want total bill to be displayed. So we are going to have a facet grid. We have 4 different variables. So this is like especially very easy in Seaborn, but it can be like hard in Matplotlib. This is the beauty of Seaborn, yes. Another one, we are going to have both tip versus total bill. So total bill on horizontal and tip on the vertical. So what's the difference here? Here we had 1 variable, here we have 2 variables. Very good example. Now, example number 2, the same thing but for IRIS datasets. The columns are species and you get a histogram for each of them. So three different species. How many species we have? We have three species and then three columns here. Each column species is something different. And you get this histogram for sepal length. And one more example here. So we have dataset tips. Columns equals size, hue equals column equals size, hue equals size, and total bit versus tip. So let's have that. And we have different columns. So and we have 6 scatter plots for 6 sizes that we have. Size 1, which is just one person going to restaurant, not that many often happens. Size 6, again, not that often. Size is usually 2 or 3 or 4. So hue is size, column is size as well, and column wrap is 2. So each, we want to have only 2 columns. Okay, regression plots. Use SNS.lm plots, and the format is as always X and Y and DF. For scatter plot, a long regression line. So we use LM plots for that. So you might say that, ask that, what's the difference between LM plot? So essentially LM plot is scatter plot with regression line, and reg plot. Reg plot was essentially the same thing, yes? And they are very similar. However, reg plot performs a simple regression, a linear regression model, fit and plotted. LM plot combines reg plot and facet grid. Okay, we're going to see about that in a little bit. For example, here we have something like this. So I'm running this. So here I'm saying that X equals total bill, Y equals tip, as always. Data tips, column equals sex. So we have like different columns, yes. We have data for, like, let's say male versus dinner, and then markers equals different things, and sorry, row equals time. So we have two different times, lunch and dinner, and columns is also for different people. So it's a facet grid as a matter of fact. And then yeah, so LM plot combines reg plots and facet grid. You can also have like more options. As you can see here, males are like O's and females are like, say, V. Here we call sex, and then so you have different options right here, and then so male versus female, they are depicted with different colors and different markers, and yeah, so this is not a facet grid though. Okay. With that being said, let's talk about one more example where we, for example, set the y limit. You can always do that. Yeah. You want your y limit to be between -2 and 15. You can just say axis equals LM. You can have axis and then set the y limit on the top of that. You can have also overlaying plots. For overlaying plots, you can overlay plots on the top of each other. This works the best with with plots that they display similar information, or and like they display information in similar fashion, such as violin plots and swarm plots. So if you have something like that, you can approach it like this. Yeah, you said you set the size and then swarm plot, violin plots, and everything. Yeah. Okay. Style and color. You can have the style and color. For example, you can have context. So from set sns.set, we can set the context. We can set the style, both of them. And you can easily just Google what kinds of context we have or styles we have. But style can be like white grid, or classic, and then context can be paper, context can be like notebook, and mm, sex versus tip. Another one, we are going to use the classic, so format that we have. So that's also easy. plt.style.use classic. You can have different contexts. You can have context equals notebook. You can have context equals talk. So different contexts. Or you can have context equals poster. All of them are possible. In order to customize the axis of a plot, you assign the axis plot on x variable. After doing so, you can utilize the set function to change aspects of the plot, like limiting the displayed values on x and y. What are we talking about? So let's say that we have, okay, we don't need this one necessarily. X equals SNS box plot, X equals age, and data is Titanic. Yeah. So we have that. Although if I don't do that, I get poster, which I don't like. So I'm gonna have that context equals paper. So here we have age of different passengers, but I want to set I'm interested only what the age between 0 and 70. So I can say x dot set x lim 0 to 7. You can set the color, total with bill versus tip, and then male. So hue would be equal to sex, and so that example we had before. You can have different scales. For example, you can have, uh, for example, data sets that is like x is 10, 100,000, 10,000, y is 5 times 10, and then you want to plot that, but you don't want like the regular, you want the logarithmic scale. So for that, all you have to say is that x dot set x scale log, y scale log, or just one of them if you want. You don't have to mention both of them log. But if you have both of them in logs, then it's going to be a linear model. Okay, one more example here we have is bar plots. A bar plot here, dataset is Titanic, X is SIP SP, Y survived. So, and I want them to be differentiated by sex, and kind is bar, height is 7, yes. So I want my y scale to be logarithmic. So when my bar scale is logarithmic, so I have 10 equals negative 2, 10 equals negative 1, 10 equals 10 to 10 to power negative 2, 10, which is 0.01, 10 to power negative 1, which is 1/10, 10 to power 0, which is 1. Maximum survival rate is 1, yeah? So I get that one. Adding title and editing labels is also very easy. You can easily do that. For example, let's say we want a box plot, but the title of my graph I want to be box plot. So I just have to say ax.set underscore title equals box plot. Very similar to before. I'm not going to spend too much time on this. And then let's say you want to say fig.subtitle is like something here. Put the figure on title here, and you can just easily do that as well. Rotating labels, you can easily rotate labels. So again, let's say X and Y are those two data sets that we had, 10,000, 10, 100,000, 10,000, and then Y is just 5 multiplied by that. Regular scale, not logarithmic scale, but so I had this before, I don't have to mention it again. But I want X to be X, Y to be Y, data equals data, height equals 7, and truncate equals true. I want my X ticks to be rotated 30-degree counterclockwise, yes, 30-degree rotated. Last thing that we have is that if you wanted to have it to graph a couple of things together, you can easily do that as well. For example, in Seaborn, most plot functions fit nearly into one of two categories. Figure level functions, axis level function. The figure is the entire canvas or window that the plot is placed within, while an axis refers to a specific subsection of a figure. This is essentially how matplotlib operates as well. So let's have an example here. I want a figure consisting of 2 by 2 axes. I do that, I get this results. Let's take a look at this and let's see what's going on. So I say fig comma axis plt subplots n rows 2 and calls 2 fixed size 9 and 6. This is exactly like before, no difference. But I'm going to have sns.regplot here, exam1 versus exam2, and then data set equals df, and x equals axis 0 and 0. And then reg plots, and then another box plot and bar plot. So everything that I'm interested in. And at the end, you can have a title for each of them. For example, if you want to have title for X levels, so you say the X 0 and 0 dot set underscore title exam 1 versus exam 2. You get here. You can have 2 rows, 3 rows, 2 columns, 3 columns, 1 column, 1 row, whatever you want, and then inside on each X you can do whatever you want as well. Just this is the format, and I prefer having this plt.type layout, so I know what's it's just easier to display. Yeah. Okay, with that being said, we are done with this SNS or Seaborn dataset, Seaborn lesson. Thank you very much everybody for listening, and have a good time.